let's go ahead and get started. First of all, a few logistics. I think I only noticed a couple of quizzes and homework problems submitted when I checked this afternoon. I think that's fine if you need some extra time getting the textbook and whatnot to get everything submitted. But do that as soon as possible. Make sure you get the textbook and start doing the quizzes and start doing the online homeworks. Because this is just not the kind of class where you want to fall behind. We'll have a lot more stuff to do this coming week and so on and so forth. Were there any questions about logistics of how to take a quiz, how to submit, see answers? Go ahead. Well, I'll say a couple of questions that came up in other classes. One was a few students missed the point that the Excel exercises are described in the back of each chapter. So you'll have those Excel sheets, the data sheets, which you can log on to and open up in Blackboard. But for the actual instructions, there's text at the end of each chapter. There are a separate batch of problems after the regular problems. Okay, so there's that. And one other thing that some other students didn't understand when I said it briefly in class 1 is that you can view all the answers to your quiz once you submit it. How you'll do that is you go to My Grades, you'll click on the quiz, quiz 1, quiz 2, whatever, then you'll click on the score you got. If it hasn't been graded yet, you just click on that yellow Needs Grading bubble, and then all the answers, your answers, and all the instructions on how to do the problem will come up. And that, of course, is key for you to understand if you made a mistake, see why you made a mistake, and just be able to do that problem fluently. That will help you going forward, because everything in this class builds. You need to understand the z-tables, then you need to understand the next concept, and everything builds on everything. You'll see that. So it's important you understand each step for that reason. And additionally, as I mentioned, once you get to the final, that's just the quiz in a slightly different format. I'll take quiz questions, literally the same ones, and just change around the answers and have you do that for the final. I'll do that for most of the final, and some of the final questions will be a little bit more challenging than that, but not quite, not very much. Any other questions on logistics? Yes?
Do we submit all the homework questions or just the Excel? 'Cause I know the Excel.
Just the Excel.
All right.
Yep, the homework problems in the syllabus are recommended homework problems. As I mentioned, I have had feedback from students that once they do the homework problems, the quiz is pretty easy. And in addition to that, I think I pointed out, there's just a few homework problems. Maybe 5 or 10 for this week, and maybe 10, on average 10 per week. So I've looked carefully at each of those homework problems, and I've decided it's going to be worth your time to do it. So that's why I suggest you do it. Other questions?
I have a little thing with
Yeah.
chapter 2.
Okay.
Got the mark, but I didn't get the rest. I looked it up, I tried to find it, but you can't go to the locker and look it up the right way.
For the Excel?
No, the Excel, I got chapter 6. Yeah, it was the part with, I had got the meaning in my,
You're talking about the Excel exercises,
Right.
chapter 2, number 2?
yeah.
Okay. So for that one, it's you need to do basically a data analysis edition, right? Y'all remember that one? You need to do the data analysis tool pack,
Right.
and in the back of the textbook it tells you some direction of where to do that.
I didn't get the textbook there.
Okay, yeah, sorry. You're gonna be flying blind until you have the textbook, and so you don't need to submit it, of course, until you get the textbook.
I have it now.
Oh, you got it now?
I just got the textbook now.
Okay, yeah. So then at the end of chapter 2, number 2, it'll give you some direction on that. Sometimes if you're working on a Mac, it might be a little confusing. You just have to do a little configuring and shake it around.
Yeah, I had some issues with that because it says find, because I couldn't define analyst, the analyst,
Analysis tool
the
pack or
analysis,
whatever.
right.
Yeah.
So it says add in, so I try to add it in and I still couldn't find the group where it was at, and it wasn't showing up, so I'm gonna do it all over again, but
Okay.
I still submitted what I did, and But
Oh,
I'll do
okay,
it.
yeah, and for the Excel exercises, if you need to submit them a little late, and also if you submit them partially completed, sometimes what I'll do is I'll give you half credit,
Okay,
and I'll say you can resubmit it for full credit,
okay,
and you can do that with the Excel exercise.
okay, no problem.
Now, the quizzes are a different story. The quizzes, you just get one shot, and sometimes students, they miss a question or two, but that's not a big deal because you've got lots of quizzes where you can make that up. And you've got the Excel exercises, which should be 5 easy points, and then plus the final, as I mentioned, is easy because it's just all the Excel, all the quiz questions added up. Okay, so let's do a little quick review from class 1, and then we're gonna spend, oh, and one last thing on the quizzes. So maybe a couple of you taken the quizzes, most of you have not. So be sure not to discuss anything with the quizzes with your classmates. And there's some things we'll do tonight where you might say, oh, that was kind of like the quiz or whatever. So think that, but don't say that. All right. So what we're going to do is a little review from class 1. Then we'll spend the first part of class going over a couple of review problems. Give you a chance to work out some of the homework problems and just look at them together as a class. And then we're going to look at sampling. All right, how do we sample for a mean? Like we want to know the average income in a certain town. All right, that's a mean. How do we find it? Well, we need a sample for it, and there's a process for sampling for it. And there's this really cool thing we can do, which relies on what we know about the normal distribution to indicate how confident we are that our sample is accurate. So, review questions. What is the normal distribution? I'll go ahead and take these the first time through, and then maybe I'll ask you all the second time we go through. The normal distribution. So if we have a bunch of data, and we plot that data on a frequency distribution, it will often fall into what we call a normally distributed pattern. This is that classic bell curve with the mean, medium, and mode, the center, and the highest point of that bell curve. There's an equal probability that you might have a slightly higher point of data or a slightly lower point of data. In one of the examples we used last time, suppose we're measuring trees. The probability of being a little bit shorter than the mean or a little bit taller than the average tree would be the same. The probability of being a lot taller than the average tree or a lot shorter than the average tree, those two probabilities would be the same. That would be a normally distributed pattern. A lot of things in nature fall into this normal distribution if there is nothing skewing the data. We looked at a couple things that might skew the data in examples we talked about last time. Suppose we have one super tall tree that is incredibly unusual. That potentially could skew the data. Suppose we have something going on with everyone chopping down all the short trees because that's the rage in Canada. Everybody in Canada wants a little short tree. So now you don't have any short trees, so that makes there's nothing on the smaller end of the distribution. That would skew the data. In absence of that, things will often fall into this normal distribution. What's great about that is it is predictable in terms of what percentage of the data will be within a certain range. And the range, the way we calculate range, is something called standard deviation. Standard deviation is the average distance of each data point from the data center. So on average, how different is each tree from the average height of a tree? Is it a very large number? In which case we'll have a large standard deviation, a wide dispersion of data, and then that bell curve will look short and fat. It will be sort of a long range, that bell curve. If, on the other hand, most trees are right about the same height, then we'll have a small standard deviation. We will have a tall and skinny distribution where all the data points are pretty close to the data center. Now, once we understand standard deviation and we understand normal distribution, what we can do is we can give each point of data a z-score. Remember, a z-score is the number of standard deviations any particular point of data is above or below the mean. If we have a super tall tree, it might have a z-score of 2.5. That means that particular tree is 2.5 standard deviations above the mean. What's useful about that is we can look at that tree, we can say, well, if it comes from a population that is normally distributed, we know that there are 98% of trees that are shorter than that tree and 2% of trees that are taller than that tree. We can calculate that with the z-score. Now similarly, if we're looking at a different pool of data, say babies in Australia, that is also normally distributed, we could look at a certain baby that's a little bit taller and say that baby has a z-score of 2.4. All right, that baby is 2.4 standard deviations above the mean. And we can look at the same chart and say the chances of that happening, 2%. That baby is in the top 2%, just like that tree in Canada is in the top 2%. And we can compare how unusual each point of data is or where it stands with the rest of the data with that z-score. So we talked about normal distribution as a review, different data sets such as trees in Canada, babies in Australia that are normally distributed, standard deviation, what is the dispersion, is it very tight, is it very wide, what is standard deviation, how can two sets of data with different standard deviations both be normally distributed? Well, they both have very large numbers. They both have nothing skewing the data. So often, when those two things occur, things will fall, this data will fall into a normally distributed pattern. It doesn't happen all the time, but it happens a lot of the time. How do we standardize two sets of data on a normal distribution? Well, so what we do is we take that pool of data with trees in Canada, we say what's the average height, that is 52 feet, we're going to call that 0, and we're going to put it on the normal distribution. Then we're going to see what is the standard deviation of trees in Canada. Well, maybe it's 6 or 7 feet. So we're going to call that standard deviation 1 on the normal distribution. Similarly, we're going to look at babies in Australia, perhaps. We're going to say, what is the average height of a baby in Australia? Well, that is 22 inches. We're going to call that 0 when we put it on the normal distribution. What is the standard deviation of height of babies? Say it's 3.2 inches. We're going to call that 1 on the standard deviation and put that on the same graph that we put the trees in Canada. Guess what? They're going to look exactly the same, and the percentage of data that is within 1 standard deviation in both populations is predictable. Predictable based on the z-table that we learned to read last time. What is the z-score? We went over that. Why is the z-score useful? All right, I think we went over all those review questions. Any questions at all about that? Fantastic. So I want to take a few minutes just going over some homework problems and give you some time to work them out in your groups. I'll come around and work with you a little bit. Then after I give you maybe 5 or 10 minutes to work on this first problem, we'll come back together as a class and just make sure we're feeling really good about reading the z-table and interpreting it with these word problems before we move forward. So, I'll pull up this on my textbook. If you have your textbook and calculator, pull them out now and turn to page 210 and start taking a look at number 16. Alright, I think if you need to, you can send a representative from your team up and to read this and start working out and part A is seen here, but we'll do, I think there's a part C, D, C, B, C, and D. I can remember the alphabet. Do those as well. I'll scroll up as necessary. So, yeah, work on this. Turn to your, and kind of, divide yourselves into teams. Explain to your neighbor how it works. Explain to your neighbor how to use the Z table if they got
Okay, so yeah.
confused.
I got the way I got it wrong for the details. I need somebody to know. I didn't do it, but I bought it.
Yeah, I mean, you got the camera, you got the book? I got it in my phone too, but I'm just gonna pull it up on my computer. Hey, how's everything?
Is
Yes,
anyone
yes.
not using their
How you doing?
computer?
I'm all right. Yeah.
Shake it around a little bit.
Do you know how to do that?
Kinda.
Kinda.
It kind of gets confusing with the wording sometimes.
Right.
But I did the homework and I got everything right. I think I got like one step wrong on one of them, but I got it right.
I'm not using my computer.
You're not using your
Well,
computer?
it's basically the formula anyway.
Yeah.
Hey, hey, all right,
Do
we
that,
got
that, subtracted that,
Right.
divided by that, and then look on the table.
We've got volunteers.
But see, when I took the quiz, that's what I didn't do. I did all that work, but I didn't look at it. So I didn't further break it down.
Oh,
To
okay.
the decimal shape. That's got about 3 of them wrong because of that. But I did, when you
Well,
look at it,
not necessarily wrong. Just didn't do
I
like the
didn't
last.
finish, right?
Yeah.
So I would get, all those partial.
But he might still give you like
Yeah, I mean,
credit. I mean, it's not wrong. It's just
I didn't finish it.
right.
So, I mean, that's as long as you understand, I understand that.
Right.
But see, this class is good enough for me.
Nah, we want A's.
Right. I can take A's and anything else. So it's, I can live with a blemish. You know what I'm saying?
Send me pictures.
Yeah, so you subtract the average from the value, right? Divided by 1.9.
So the one that you have at home
Find the probability.
We doing number
Because
16.
that first number is.
that's how it was sold. No, I bought the binder.
And then in this case, we have.
So
It's
what,
just
so what
sold
is
like
it,
this. You gotta buy the binder.
Yeah, between, so you're trying to find
So we trying to find the percentage. I guess that's gonna be between 5 and 6 million.
right. So on the table, we go to what, 5? So what we do 5.6, and then 6.5,
For what?
and then subtract. Do you subtract?
Yeah.
So it's X minus
Yeah.
mean,
Yeah.
And then
Yeah.
subtract,
Yeah.
right? Because we go under.
right? That gives, for 5 million, that gives us negative 1.36.
We did one like
Beyonce.
So there's two values, 5 million.
I'm sorry, I'm trying to-
6 million, right? So we need to find the z-score for both.
So we got
You forget, right? 'Cause
Yeah. So it's here, it's just not the same.
for z-score, we find
We find a z-score for both.
yeah. The z-score for both and then subtract it.
Right. You did that?
This is something we did last week, but it's
Right.
kind of like the same thing with like
Same
between 2
thing,
points.
I did this one already at home. I got 2 points.
It's
That's one for that.
5 and 6. Okay, so we gotta do. So we gotta do 5 minus
X minus
6.5 and then divided by 1.1. So we gotta do that for 5 and then do 6.
Right.
Makes sense.
This is like,
I'm trying to make sense out of it. Doing it with the picture.
And then
Set it up like, see how I set it up right there?
Right, the
The X
6.5.
value, the Z score, find the Z score for 5. Remember how to find the Z scores? Okay. And then all you need, once you have the Z score, is the area under the curve. So you know where the, in the back of this, you have the Z table. What's your name?
yeah, I'll be trying to get my
What's your name?
the ball.
Devon, okay. And what's your name?
Here we are.
So it's 5, 6 minus.
You get this part?
the area in between.
Oh, so you got 6 and 6.5.
Yeah, because the 6.5 is like the mean,
Right.
but we're trying to find it between 5 and 6.
5 and 6.
So then 5 minus the mean, and then we divide it by the standard deviation.
Right, right.
So we do that for 5, and then we do the same thing for 6.
Got you. Because
Then
we
we,
looking in between 5 and 6.
right.
I got you.
And then we find, once we get this, we find the z-scores on the table, and then we subtract
And then we
those
subtract.
two, yeah.
Got you.
This one, okay.
But then because they're negative, remember like the thing with the negatives?
So then we have to, so when it's negative, what do you say?
We do the positive and then subtract it from 100, and that's the negative. So like instead of -1, we would look for 1 on the table.
Right.
Subtract this by 100, and then that would be the negative.
So it'll be, right here, 1 would be,
What?
So we would do 84.
subtract it from 100.
100, what did you say? 84.13.
And just subtract it from 100.
Yeah.
Got you.
So 15.87 would be the percentage.
So again, what you said?
15.87, because the z-score for -1 is 84.13%. So then we would just minus that from 100%, and then that's the -1 z-score.
I got you.
Yes, ma'am.
So I just wanted to see if I'm doing the right area. These are the two Z-scores, and then we're adding them.
You want to figure out the logic, like, am I looking at the curve, the logo?
Let's actually just do that. Because you need a whole.
Subtract that.
Let's give you a whole. Are we ready to do part
So
A?
it's at 32
class?
cents.
64.
Yes. One more.
All right, one more.
Oh, you just wanted A? You didn't want B and C?
No, keep doing B and C, but we're gonna do A, B, C, and if there's one after that, do that too. There's not one?
Nope, there's not.
Okay, A, B, C.
And then subtract.
And then subtract these two percentages, and then that's the answer.
Sit up in front of the class.
It'll be 16.
Yo, my man, what's going on? You doing good? How are you?
I'm not.
Someone there? Someone's
Yeah.
here?
Well, the camera's here. I don't know.
Yeah,
Do you wanna squeeze back there? What do you wanna do?
But you have to move your
I
camera.
think this is the only computer that's available.
Yeah, this
I have to move your camera then.
No, you can't move the camera. You're crazy. You move the camera. You've been here 2 minutes and you wanna move my camera?
It's too much, too soon, too soon. My apologies.
You can sit up there if you want. Or you can squeeze in there.
Do I need a computer?
No, you don't.
Oh, okay, cool. Yeah.
Or actually, Ariel, you're at that computer, right? Do you want to squeeze in between the camera and Ariel?
Whatever works.
Okay.
Sounds good, thank you.
you messing with my team, man. Huh? Squeeze. Yeah, you messing with my team. Huh, squeeze right here.
Or maybe you can squeeze on the other side of it.
You guys need another team member?
Yeah, but
What if we move this?
Standard deviation, that's my thing.
No,
come right here. Sit right here. Sit right here.
Whatever you need.
I got you.
It was real bad up there.
I got you.
All right, let's go ahead and get started on this problem. We'll do A real quick, and then I'll give you a few minutes if we need to do B and C. So this is a situation where we've got estimates on a construction project. It's a lot of money, millions of dollars for this construction project. So this company, perhaps they've hired you to do the statistics to figure out the likelihood that they'll make money given their bid amount. And this is kind of an interesting one, I think, because if you think of a construction project, maybe you've heard stories about all the disastrous things that could happen when you're working on a construction project. It can make it cost a lot more, but if everything goes according to plan, then it'll be very inexpensive. In any case, this company has decided that there's a distribution representing costs for this construction project. They think the average and most likely cost is $6.5 million. Could be a little bit more, could be a little bit less. A disaster could strike, could be a lot more, or it could be a lot less. They have asked, what is the probability of this actual cost being between $5 and $6 million? Perhaps they need that for some sort of funding. They say if it's $5 million, we can get this kind of funding, but it's more than $6 million, we can't. So, whatever reason, they need to know the likelihood. It will be between those two. So, you need z-scores for both of these, and you need to find the area in between. The way I like to set up these problems is first one row with the actual data points, and I call that X. You'll see X represent data points. The next row I like to put Z to make sure I'm not confusing the data point with the z-score. And then once you calculate the z-score, you can put a third row for the area under the curve for that z-score. So for the 5, let's get the z-score for that. Z for 5 equals the actual data point 5 minus the mean of 6.5 divided by the standard deviation of 1.1 equals what?
Negative 1 minus 1.36.
Alright, so we've got Z for 5, negative 1.36. Alright, how about Z for 6? 6 minus 6.5 divided by 1.1 equals what?
Negative 0.45.
Negative 0.45?
Yes.
Excellent. Negative 0.45. Now, do you remember how to find the area under the curve for each of these 2 points? So you find the area under the curve for this one, perhaps, and then you would subtract off the area under the curve that's below 5. You with me on that logic?
Mm-hmm.
Yeah. So what did? Let's actually do this one. So what would be the area under the curve for negative 0.45? How much is to the right of that data point? What percentage of the data? Negative 0.45.
Yeah,
No, you gotta add
actually,
20.
I got 29.
32%?
Yeah.
That's to the left.
Alright,
I got
30.
29.12. I'm not.
Oh, getting a little
Okay,
crazy.
so
The numbers start getting crazy.
let's do it this way. Alright, let's just say we only had a positive z table. Now in your textbook you have a negative z table, so you can go straight to the negative side. But just suppose you only had a positive z table.
Right.
So let's look up 0.45 positive. Alright, you look that up on the z table, what percentage of the area is below to the left?
That's a
To the left of this.
67, 36.
736?
0.67.
67.36. Okay, so 67.3% of 0.36% of the data is to the left of this. That's positive. So what do we need to do if we're looking for negative 0.45?
Subtract by 1.
Subtract it.
Take 1 minus this.
Yes.
Alright, so 1 minus 0.6736 equals what?
Right, I do, so I have that right.
0.3264.
3264. Excellent. So the area below this, the left of this, is 0.3264, 32.64%. To the left of 6. Now that's not our answer, because we need to subtract off this little tail here. So we find the area below negative 1.36 using a similar process as we did here. And we find 0.0869. And now we just subtract, take the difference between these two. It's going to be the area in between.
I have 23.95.
23.95? I like it. So that is the answer to part A.
This would have been
23, very close to 24%. Makes sense?
Yeah, if you have, if you find this and this.
Okay, let's just do, should we just do the next one together?
It's the same. Am I right?
No, it's easy. So the standard deviation was
So how likely is it that project costs will be no more than 7.2 million? So that means less than 7.2 million. Right? Maybe 7.2 million is our bankruptcy point. Alright, we've tapped out all our creditors, we've invested everything in this, and if it costs more than 7.2 million, we're in trouble. Well, luckily for us, we know this is normally distributed data. So 7.2 is the data point. We want to know everything to the left of that. First thing we need is a z-score for 7.2. So z 7.2 equals 7.2 minus 6.5 divided by 1.1 equals what?
63.
0.63.
63.
Yes.
So
64.64.
Oh, you can, oh, yeah, because
Yeah.
it's right.
I rounded it.
0.6363?
Yeah, so that's
Rounded it
0.64
to
like you said.
0.64.
You can round the 6 to the 4.
0.64.
Right.
Very good. All right, so 0.64, that is our z, 0.64. Now this one is easy. All we need to do is look up 0.64 on the z table. That tells us the area to the left, area under the curve for a data point with that z-score. So what do we see when we look up 0.64 on our z table?
73.89.
73.89. So the answer is 73.89% of the data is to the left of that. That means 73.89% of the outcomes, possible outcomes, involve costs being less than 7.2 million. we think? Good? Good? All right. I like head nods. Excellent.
I can't use this detail, can I? Can I use this?
Yeah.
We do the last one.
See,
Where did you find the .64?
All right, so in this case, the company
Oh,
bid
so go to 4.
8.1 million.
6 and then go to 4.
They didn't bid 6.5, because then there's only a 50% chance they'll make profits. They bid 8.1.
And the tables on your.
We want to know what's the likelihood the project bid cost will exceed the bid amount. The cost will be higher than 8.1. So in this case, we're looking for all the possible outcomes higher than 8.1. This is the little part of the tail that we're looking for. So we need z-score for 8.1. Let's start there. Z 8.1 equals 8.1 minus 6.5 divided by 1.1 equals what?
1.45.
1.46.
Right, I like it.
1.45. Thank you for telling me to
4.5.
round it about. No, 4.5. Yeah, it's a 4.
1.45. All right, so the z-score for that outcome is 1.45. When you look up 1.45 on the z table, what do you see?
0.9265.
0.9265. That tells us what? 92.65% of the data is what?
Everything from 81 below.
Below. All right, is that the answer we're looking for?
No.
No, we're looking for above. So we need 1 minus this.
Yeah.
If it helps you to remember, you could just say 100% minus 92.65. You know, the whole thing here is 100%, and this is 92. And that leaves us with what?
Yeah, 0.0735.
0.073.
No, I don't get it now.
All right, 7.35%.
Correct.
All right, so that's the chance that it will exceed our cost. Our cost will exceed our bid, and we'll be just wasted 4 years in this project and lost money.
That's super hard. Maybe like, yo, can I do beyond below? You like what? Black.
All right, so I can address questions on that, but if you're good there, go ahead and move on to the next one. What is it? It's page 213, exercise 22.
This is older,
That's the, what, the second edition?
Let's take a stab at it.
No,
Yeah,
it's
so
not
they did the same thing, they sent me the wrong book.
Yeah.
How much did you pay for this?
Oh.
Oh, yeah.
Nothing?
Yeah.
Alright, so I've got the table. Yeah, I've seen this one before and I've looked at them, and you're just gonna be frustrated because we rely so much on specific problems.
No worries.
And the Z thing is not
got
even
that one,
accurate. So, no, I rented it, they sent me the wrong book, but luckily I do have the right copy at home. And it wasn't until I got here, that in that copy at home, that I realized that it was just these 4 tables wrong. Yeah, yeah, because
Like literally wrong.
yeah, I would think it should be this one, right? It should be this one. Yeah, that's the one I'm pointing at.
I'll pull up 22.
When you compare these, no, these years are 12. We did regular math. No, regular. It's
No,
over
just
there. You see, look, yes, we did regular. Even the first one, it's actually smaller than the air.
I have the air.
It's a lot lighter.
Yeah.
Yeah, I found it like, it's crazy. I compared this to the air and I looked at that.
No, no, I have the whole book. I just think like,
The air is much bigger.
they was ready for my download.
But you get
Shit, I
it.
usually fuck with my computer, but for some reason, that shit. So you just wear glasses and let us see.
I wear glasses too. Like, I don't have my friend.
And it's a 5 years. So what it be like? So let's see. But I'm thinking, this is what I'm thinking.
Right.
Could be. Right. Right.
So we're trying to figure out the average. We're making a bit of how far the average rate of return is. Our X value is zero. So we have to do mean minus, sorry, X value minus the mean minus the deviation. Zero, yeah, same thing, 0 minus
So 2.
I have to bring the percentages. That's why.
It's negative.
I feel
Doing all right. So, is this considered, so the Z0 up there, is that still, Z-score formula?
Yeah, see, it's asking what's the probability of being negative, so meaning less than 0.
Right.
It's a little confusing in this one because the X values are in percentages. So it's 0% return or 5.1% return. So what's the probability of the return being 0% or less?
Gotcha.
So it's 120.
Oh, I'm sorry. trying to do the Z-score, I figured doing the answer. Zero minus, so this has to be 20.22. Yeah.
So no, it wasn't a negative. Final answer. Remember I asked you, was it a negative? You know, first, for the question.
What is the likelihood of the therapy that average and then the time that was there and
Between 2%, 4%.
Z-score? I got 2, 2, 4, 6, 6.
Z-score. 2.2.
I'll be wrong. 0 minus
5.1.
The shit says change.
Which one you doing now? Oh, B? So what was B? I
the
didn't know.
two, like the two charges.
Right. So you gotta do it for each one.
Yeah, for both of them.
So you got 2 and 4%?
Yes, I have.
So this would be, I'm sure. I was, yeah, we going. No, it's alright. You know, we're glad it wasn't. That's right. What you got?
For B?
It's a negative one.
Yeah, try C and D, those are hard ones.
Yeah, that's why.
That's why you stopped.
Yeah.
Fair enough. Well, for those
Like,
ones, for those ones, what you need to do is you need to do it in
reverse order than we've done it in the past. You'd actually look in the center for 95% or 25% and say what z-score is associated with that.
We did that last week.
Yeah, but then it's.
We did that last week.
Or CND.
I like that.
Oh, not Andy.
Yeah,
For CNZ, so it's
Oh, okay.
probability. So then I heard over there cross multiply. So can you do that?
Yeah, what you do is you work backwards.
Right.
You are given,
And then that's the
I
answer.
think you're given like this, the actual data point.
Uh-huh.
And, wait, no, you're given the area under the curve, right? Given the area.
Yeah.
You're given the area under the curve. You say what z-score is associated with that, and then what data point would have a z-score of that.
Gotcha.
And that's where the cross multiply. You would like, this would be your unknown factor, and so cross multiply.
Okay. So just reverse engineer the whole thing.
Yeah. Speaking of which, are we ready to start this one?
Yeah.
Yeah.
All right, should we do it? All right, so in this question, we've got a bunch of data about IPOs, specifically the average 5-year return on an IPO. So IPOs are these hot new public companies. Everybody says, or the investment bankers say, this stock is going to make a bunch of money. If you know us and you get these initial shares, you'll be rich, so hopefully you know them. If not, you have to wait and buy it later. So these researchers did some research on what was the actual return of IPOs, and they found that the 5-year average return, 5.1%, with standard deviation of 2.2%. So, if we use this to indicate future performance, if you are to invest in the next upcoming IPO, what is the probability that your return will be negative?
1.02.
That sounds right. So 1%?
Yeah.
1%.
2.07.
Yeah. All right. Let's calculate that. So negative meaning less than 0. So this is a little confusing because this x, this data point, is in a percentage, but it's different than this percentage. Right? It's a percentage return. So a 0% return would be the dividing point between positive and negative. So let's find the z-score for a 0% return. So 0 minus the mean divided by the standard deviation gives us what?
-2.32.
-2.32. Very good. So we've got a z-value of -2.32. So it's really just a question of what is the area under the curve below -2.32. The only tricky part would be is if you have to do a 1 minus thing if you don't have a negative z-table, which you are fully equipped to do. So what do we get for the area under the curve below -2.32? 1.02%. Does everyone like that? Yeah?
Yes.
Alright, so we like it because we understand it. Also, we might like it because there's a very low probability you'd have a negative return. So I guess those investment bankers are right. You know, invest in their new hot IPO, and there's a tiny, tiny chance you'll have a negative return.
Professor, real quick, from
Yes.
the 2.32 to the percent, to the negative percent, well, not negative percent, but
Yeah,
can you go from there?
yeah. Alright, so,
Because I got
the
that.
only trick I
but
said is if you don't have a negative z-table, you would have to look at the positive 2.32 and do a 1 minus deal.
Oh, okay.
So let's look at positive 2.32. So do you have a z-table, Nick? Yeah, you have a
Yes.
z-table. Yeah, look on the z-table and tell me what's the area under the curve for 2.32.
0.989.
0.989.
9898.
Okay, so that's all of this, right?
Right,
And what we want is this.
yeah,
So 1 minus will
Yep.
give us this little tail.
got it.
Fantastic. All right, so what's the probability the return will be between 2 and 4%? Well, let's put 2% up here, and let's put 4% up here, and then let's find z-scores for both of those, and then find the area in between. Good plan? Get this out of the way. All right, so z2 equals 2 minus 5.1 divided by 2.2 equals what?
Negative 1.4, so.
Negative 1.40?
09.
Yeah?
So you can round it to 1.41.
Okay. Negative 1.41. Z for 4 equals 4 minus 5.1 divided by 2.2 equals what?
Negative 0.5.
Negative 0.5, yes. Negative 0.5. Alright, so we've got our two z-scores. All we need to do is look them up, see what the area in between the two of them is. And when we do that, someone want to just give me a final answer?
22.92.
22.92? Alright, so 22.92%, very close to 23% chance that our return will be between 2% and 4%. And then how did we get from here straight to here? Well, for these two, we looked on the z-table. Maybe we had to do a 1 minus deal, draw a picture, keep track of where we were, don't do it when you're stressed out, and make sure you're adding and subtracting where you need to add and subtract, and you come up with 22.92%.
So if you had 23, that would, you'd be okay too with that?
No, don't round it, just leave it like that. Leave it in 4 decimal points.
Rounding it, I don't know how to get it off of that. Like, that's what my calculator is automatically rounding. I don't know how to take that feature off.
Alright, well, take a look at that. See if you can maybe extend the number of digits. Alright, now the next two are a little more exciting. We have to do this in a different direction than we are used to doing it, but that's okay because we have all the tools to solve problems parts C and D. Question. There's a 5% probability that the stock had a 5-year annual return of at least what percent? So it's asking us for what percent return. So it's asking us for this percentage return. That return or greater than that return. What it's given us is the area under the curve. It's saying there's a 5% chance. So there's a little 5% section somewhere on the curve it has asked us to identify. Where is that 5% section?
Negative 1 point, the z is negative 1.7?
Where's the 5% section? Is it right here? Is it somewhere in the middle? Or is it right here?
At the end.
It's at the end.
That way.
You like it here? Deanna likes it here?
Yeah.
I think.
Alright, I like that.
I like
It
that
is
too.
this 5% section that we seek in X percentage 2. Alright, what percent return do we need to have to be in this 5% section, this part here, or above? And there's no real statistics logic here, it's just the way the question is worded. You just have to look at it and think about it. Average return of at least blank percent. So that's saying some percent or more. That's the clue that gives us, that tells us we're looking for something in the upper tail. Some percentage in the upper tail, and it's 5% in the upper tail. So that's the first step. Let's make sure we're clear on that first, because the rest is not too hard, but it's just something we're not used to doing. So is everyone like why and how we selected this 5% tail? Does anyone not like how we selected this 5% tail?
You selected it because it said at least
Yeah.